Okay, the topic we're going to do today is integration. And integration can rather be called antiderivative. Antiderivative, recall from the differentiation that finding the derivative of a function, that is, finding the differential coefficient of a function, is what we call differentiation. So the reverse of this process is what we call integration. From the idea of derivative, let's say if dy dx, that's the derivative or differential coefficient of a function, is f prime x. This is the derivative of a particular function. To get the function whose derivative is this, then we use the technique of integration. So how is this achieved? We move dy will be equals to f prime x dx. To remove the d sign, so we can get the original function, we introduce a sign called integral. So the integral sign says dy equals integral of f prime x dx. So that gives us y equals integral of f prime x dx. So the f prime x is in form of a function. So let's say if f prime x is equals to a x raised to power n in general, meaning y will be equals to integral of ax n dx, which a technique we have developed says that to integrate, these are what we are going to do to the values in the integral. A x n plus 1 all over what? N plus 1, which means we are adding 1 to the power, to the existing power of the variable, then dividing the whole expression by the new power. By doing this, we have integrated plus c. C is an arbitrary constant that is always added to any value of the integral that has been integrated. Example of such is, we are asked to evaluate integral of 2x dx. This is a very simple integral solution. The 2 here is serving as our a. The n here is serving as the power of x, which is a variable, which is 1 as far as this expression is concerned. So what the technique told us to do is that we have integral of 2x dx. We are adding 1 to the power of x. So meaning we have started integrating. Once you start integrating, you remove the integral sign. So we have 2x 1 plus 1. The power of x is 1 initially. Then we increase it by 1 all over 1 plus 1. So which eventually gives us 2s squared over 2. Then 2 goes with 2. Then the integral becomes s squared. So the original function whose derivative is 2x is y equals x squared. At the same time, we can also look at another example that says evaluate integral of root x dx. It is very simple. Using the techniques in indices, we have integral of x raised to power r dx. The coefficient of x that happens to be our a here is 1, and the power n is r. So using the same techniques, we are going to have x r plus 1 all over r plus 1. And r plus 1 will give us 3 over 2. One whole number, 1 over 2, which is equivalent to 3 over 2. So there we have x raised to power 3 over 2 all over 3 over 2. X raised to power 3 over 2 times 2 over 3. So that gives us the square root of x all raised to power 3 times 2 over 3, which gives the square root of x raised to power 3 times 2 all over 3 plus c. So this is the original function whose derivative is root x. whose derivative is root x, the original function gives y equals 2 root x cubed all over 3. Please subscribe to our YouTube channel. Thanks for watching our video.